I should keep this way. You like it this way, then this is okay.
The recording also screen will appear big, sir, if you keep like this.
What we do if we do in the recording, the screen will appear bigger. That is true.
Yes,
Wait, let me try to record myself also if it is possible. I don't know if it will be possible or not. But the point is, if I use Gauss law for such a shape, then will I be able to determine field at any point using this? No. Why? Because at all the points field will be different. So if it is different field everywhere, then when I take the E dot ds,
integral we cannot take out, sir.
I cannot take E out, so it will be tough to do.
Yes, sir.
So means I have one unknown, and I will not be able to solve that. So this is like unsolvable equation for me. If I want to really solve it, then I should use some tricks to do it smartly. Although the trick was hinted here. Take a strip, small element, and that element will become like a rod, long rod. And due to this long rod only, you try to find out what is the force acting on the this flat face, rectangular face. If we are able to find out due to one, then probably we can find out due to all others also. So main idea was, can you find out due to just one rod, if it is placed here on this, what is the force acting? So let us now think about it, how to find that single rod's force. Okay. So let me make a diagram once again somewhere, or maybe I will copy it to other place and then I will do there. Not far away, here itself I will do it. Here is okay. Right. So this is the case, and if I take the rod element in this way, or any other way I could have taken it, around it I want to take a cylindrical Gaussian surface. Let me draw it. It should look like a little bit cylindrical also. If I take a cylindrical Gaussian surface around it, I can find out the field. Okay, wait a second. I don't need to take the Gaussian surface. I will just take rod, that is enough. Due to this rod, what will be the angle on the rectangular face? Any idea? Angle subtended by this on the rectangular face.
What the rod means 90 degrees.
90 degrees only, sir.
Yes, 90. Any element, not only this rod, any element when we take here,
diameter to the point also,
all these are subtending the same angle. All these are subtending the same angle. Anyway, this is not because I am directly starting from the solution. I should not do that way. I think I should lead you to the way when I did it for the first time myself only. Then what was going in my mind and how I did it. Let us start with that way. Then you will be understanding the real thought process, how I got this idea and how I solved it in this way. See, let us say I took one element. First of all, I took one element and I wanted to find out the force acting on this due to this element, this entire rectangular plate. So to do that, what I thought I know that net force is acting definitely in which direction, because it is attractive force, and by symmetry I can tell that overall the force acting on
Upwards.
this will be in this direction. From the center, obviously, it will be upwards, like this it will be acting. Then I thought, if it is acting just upwards only, then why don't worry about other components and just try to find out the force which is acting in vertically upward direction. And we have a way to do that, if you remember, for any flat face of any shape. But if it is flat, if it is one rectangular face is flat or not? Rectangular face is flat. So I could have found, wait a second, I think I said as I was trying to find due to rectangular face. So due to rectangular face on this element, what the force will be? Will it be vertically downwards or not on this rod?
Yes,
it will be vertically downwards. Exactly vertically. It will be vertically downwards. And what is the value of the for any plane surface? I derived it for disk also.
Everything is same, sir.
That the field formula at this point will be equal to G sigma omega. Omega is the solid angle subtended by this disk at this point, or any surface for that matter. It could be any surface as long as I am taking at perpendicular distance something. Perpendicular also doesn't matter, I think so. Perpendicular also doesn't matter. It should be subtending some angle, and we should know what that solid angle is. It is subtending. Solid angle means how the solid angle is subtended. I don't know you remember it or not, but I have.
Sir, but the point should be definitely symmetric, sir.
Point may not be symmetric also. Wait a second, I will tell you. As long as I am interested in finding only vertical force, then point need not be symmetric. As long as I am
only one component of force you are talking about. Yes.
Yes, I am talking about. Why I am talking about vertical only? I gave you a reason for that. Because I know that net force is vertically downwards. So it means I am not interested in any other force. I am interested in all the elements. I will find out just vertical force, and I will add those vertical forces. That will give me automatically the resultant vertical force. That will automatically give me the resultant vertical force, right or not?
Yes, sir. So, I think horizontal will get cancelled due to half side it will be left, no sir. Other half will be right.
Horizontals will get cancelled out, and yes, and this will only remain. But what is meaning of solid angle here? Here you should understand what is the meaning of solid angle. Solid angle means if I take every point on any shape which I am drawing here, this shape I had drawn here, any random shape you take first of all, and on this shape take all points on this. Don't leave a single point also, and take some small little strings and connect this single point by the strings coming out from all those points. Then we will be getting a surface. You will be getting a surface or not? And that surface will have a inside we will find some conical shape will be formed, and in that conical shape, in that corner inside, there will be some solid angle formed. Any corner can form a solid angle. I think when I was discussing solid angle, I gave example of room also. In our room, if we have a cuboidal room, then in the cuboidal room also, the corner of the cuboidal room, if you look at it, then in this corner also there is a solid angle. What is the value of that solid angle in the corner of the cuboidal room? If I take a single point here, and how many rooms this point can have, cuboidal rooms it can have? 8 cuboidal rooms it can have surrounding it.
Yes, sir. 8.
Yes, sir. 8 is 8.
4 below.
4 below. Yes,
then
sir.
what total solid angle subtended by a point in all directions will be equal to
4 pi. 180, yes, sir.
So out of that, what solid angle will go to one room? What solid angle will go to one room in this?
180 degrees, sir.
Pi by 8, that is pi by 2 steradian. What solid angle will go to one room? Pi by 2 steradian. So I have given a formula 2 pi into 1 minus cos theta is equal to omega, but that is valid for cone if it is a vertex of cone, and in that we are finding out the solid angle. But solid angle is not only defined for cones, it is defined for all other cases wherever we have a corner, and from that corner some surface is coming out. A surface is coming out from that corner, and some part will be enclosed in that, and that part which is enclosed inside that, what is the solid angle of that part, that we are looking at it right now. So let that solid angle be omega. If that solid angle is given to us, then as I did last time, let me revise it again so that you will understand the things better. Let us say I want to find out field at this place, and here this little element is subtending a solid angle d omega, and this is a d area vector will be this side, dA vector, and this is at theta angle from here. This line is perpendicular line, by the way, okay? With perpendicular line, perpendicular to the surface line, it is making an angle theta, this area. The line connecting, sorry, not area, the line connecting area and the point P. The line connecting area A and the point P is making an angle theta with the perpendicular line to the surface. So this also will be theta here. Then dA cos theta. Why I am taking dA this side? You remember? It is perpendicular to this.
Yes, sir. Perpendicular to surface of the.
It is perpendicular. Means you. I think I should.
For the body.
Let me make it better. It will take a little more time, but you should understand properly. Let me make in 3 dimension what is happening here. So this surface which I am drawing here, it could be random shape surface. It is not okay. Let it be ellipse only. No problem.
It will be on YZ plane, sir.
It is yes. This is in Y.
Z plane.
And in X plane we have a point. In X plane somewhere we have a point, and this is a perpendicular distance. Let it be given to us. Let it be something maybe D or whatever it is. And here I am taking some area element, and on this area element there will be along x-axis, because x-axis is perpendicular to it. So area vector will be pointing along x-axis. This is dA vector. Now this dA vector will be making an angle theta with the line joining area and P. Then what will be component of dA vector along this side? That will become
cos theta. Yes.
Then this is AP is r distance. AP is r distance. Then we will be getting the formula for force. What will be the force? You tell me now.
GDM.
The force will be G into dm by r square, direction along radial direction.
Sir, field no.
Field only, sir. That
Field,
is,
sir.
that is field now.
Yes, field only.
You said
That
force.
was before you are saying force. It is.
Okay, don't worry. Field means if I are able to find out the net field, then net field multiplied by mass will give us force. Where is the problem? Don't worry about it. Let it be field, then field multiplied by this rod mass. If I know the field here in this rod, then
Sir, multiply by mass we get
with the mass
force.
of. Yes, but right now it is just field due to plane sheet at a point P, which is at a perpendicular distance D. Just think right. So what is that? That is along r cap, along the r cap direction, because it will be pointing towards A. So r, I have taken r in this direction, so it is r cap direction, right?
Yes,
But I
sir.
know that sigma into dA can be written as dm upon dA, mass per unit area is real mass density sigma.
Sigma. Yes, sir.
So sigma into dA is dm. Then what do we get? dE finally equal to g sigma into dA by r square into r cap, that is dE.
Sigma
But
secant theta.
I am not interested in that. I am interested in dE perpendicular. That is the main point here. I am interested in dE perpendicular. That makes our things easier. dA perpendicular upon r square into r cap. What is the value of that fine? Not dA. Sorry, wait. I think I should take component
Sir,
of dA. Component of
DA.
wait. Let me finish, please. Let me finish. If I'm thinking, yes, there is some trouble here. Let me finish it, and after that you tell me something. If I'm still doing something wrong, let me finish first. G into sigma into dA by r square, and I should take dE perpendicular. dE is in r cap direction. If I want to take perpendicular, then it will be pointing towards this
cos
point
theta.
here, towards the origin. That will be multiplied by cos theta into r. Now I can write this as G sigma by r square into dA cos theta. dA cos theta, we notice. What is dA cos theta? That is coming out along.
They are perpendicular, sir.
That is dAr component. That is radial component of dA. Whenever we get this dA radial component, and that will be dA radial component upon r square. If area vector is in this direction and r is also in the same direction,
Solid angle.
then directly we can write it. Yes, exactly understood. We can write it as G into sigma into d omega, and it is wonderful thing. Always valid as long as we want to find out any random sheet to take. As long as we find out the perpendicular component of the field, it will always be valid. So what is this coming out?
వాళ్ళకి సబ్జెక్ట్ టీచర్
Net solid angle.
కోఆర్డినేటర్ ల్యాప్టాప్
Net solid angle. Who is that boy talking in between?
Muted, sir. Again,
G sigma omega. G sigma omega will be there. Right. Now, main point here. Now, if we come back to this, so let us come back to this now. If I am able to find out what solid angle is subtended by this line, because I want to find out the field at this line. What is the solid angle subtended at this line by the
by 2, sir.
By the
Rectangular circle.
rectangular sheets are down.
we know that a line is surrounded by if it is surrounded from all sides, then what solid angle it will be subtending on a cylinder? What solid angle the line will be subtending on a cylinder? The solid angle subtended by the line on this cylinder will be equal to 4 pi steradian if I include these parts also. Now, or any point on a line, I am talking about any point on a line. If I take any point on a line, will be subtending what total solid angle? 4 pi steradian total. Any point on the line will be subtending same solid angle. If any point on the line is subtending the same solid angle, 4 pi steradian, out of that, what fraction will go to this side and what fraction will go to this side? This and this part we can neglect. Reason is, I have given the very long cylinder. I don't know I mentioned or not. I should have mentioned very long cylinder, and radius is very, very small as compared to that. If radius is very small as compared to the length, comparatively means like 100 times or something, or maybe much larger than that, then we can neglect this part here and we can neglect this part here. If we are able to neglect this part, then the solid angle nearly will be subtended in curved surface area only. So what any point can subtend
Then 2
maximum
pi,
solid angle
sir, it
is 4
is.
pi. That total will be subtended in the
With
curved surface.
By 2 pi, sir, then.
Out of that, how much will be remaining in this when the angle is 190 degree here? Total angle would be planar angle will be 360 degree.
Sir,
Out of that,
270 degrees.
1/4 it will be.
Yes, sir, 90 degrees, sir.
It will be 1/4, right? So it will be 1/4 of that. It will be subtending there. Then we can write it as G sigma into 4 pi by 2. G into sigma into 4
Pi by 2,
pi.
sir.
Sorry. 4 pi by 4. So it will be 4 pi by 4. It will be pi. Pi
Sir,
square.
4 pi by 8. 90 degrees.
90 radian or 90 square radian. I don't know what are you talking about. I am saying what is the, first of all, I am not talking about this point. I am talking about any random point here in the inside it. And what is the solid angle subtended on that? Now only I explained that the solid angle that this will be subtending in this portion will come out to be pi by 2 pi steradian. If I have a point P here and P is surrounded by a circle and planar angle it is subtending equally. Similarly, solid angle although is not subtended in a line, in a single plane, it will be subtended over the entire area. But if I take this total also and I take a point here, then what solid angle, they take one plane here, one plane is here, and take another plane. What is the angle between these two planes which I am taking? That angle between, planar angle between these two planes is 90 degrees. Planar angle between these two planes is coming out to be 90 degrees. Okay. This diagram is becoming difficult and I have not yet, unfortunately, I cannot show you how it is happening. Wait a second, let me tell properly. Assume we are cutting it by two planes. We are cutting it by two planes which are perpendicular to each other. And we are taking a cylinder around that. And here there's a point P. So when we cut it by two planes, what part of cylinder will come to one side here? Quarter part of cylinder will come to this side.
Yes, sir.
Then on that quarter part, what solid angle it will subtend? This point will subtend. This point is subtending the total solid angle on the entire sphere. On the entire not sphere, on the entire cylinder, on the entire long cylinder, which has this whole has negligible solid angle. So the entire solid angle is only on the curved surface area. That is our assumption. And out of that, what portion is coming to this blue portion? Blue portion is coming 1/4 or not?
Yes, sir.
So the solid angle there will become 1/4.
sir.
What will be the solid angle coming in this place? It will be coming 1/4.
Solid angle.
Solid angle, total solid angle is 4 pi. Out of that, 1/4 is coming to this side. So what solid angle this P point will subtend on this part?
Pi.
Ice.
So although planar angle is 90 degree, I agree, but that is planar angle. That is angle in a plane that is 90 degrees, 90 radians. 90 degrees or pi by 2 radians, but it is steradian. So it is becoming 4 pi by 4 steradian. That is pi steradian. Understood? 4 pi was the total solid angle subtended by the point on the very long cylinder. On any, first of all, okay, let me say again one more thing again. For any closed surface, if we have a point, what is the total angle subtended by the closed surface at this point? Total angle subtended by the closed surface at this point will always be 4 pi.
4 pi.
If it is closed from all sides. Is the cylinder closed from all sides? No, it is not closed from all sides, which I have taken here. But in this also, this part, if I assume to be less and this part I assume to be less, then the solid angle going to that side and this side will be going negligible solid angle. Then main solid angle will come in which place only, in the curved part only. Then what solid angle that will, or if you want to find what solid angle goes to this side, you can find that also, because I have given it to form a cone here. What solid angle will go to the disk side? Let this angle be theta, then solid angle going there will be 2 pi into 1 minus cos theta. If theta is very small, if theta tends to 0, then this solid angle will tend to 0.
1 minus cos theta equals 0.
Yes, this solid angle will tend to 0. So the solid angle which is subtended by the plane disc parts, which is not there. There's a cavity in the disc. There is nothing there.
Nearly
But that
0,
will be
sir.
subtending 0 part. So mainly it is coming in the curved part. And what curved part? That curved part
Total 4 pi.
which is a 4 pi by 4. Why I'm taking by 4 here? Because as we know before here that the planar angle, if I take any line here on this point here, then this planar angle will be 90 degree angle, right or not? Anywhere it will be 90 degree angle here, like this.
Yes, sir.
So you think as if this is our xy plane, one plane is xy plane, other plane is that other plane perpendicular to that plane, and this P point is lying somewhere in between those two planes where those two are intersecting, and that plane will be subtending on this area angle equal to pi steradian. Is it okay now?
Yes, sir.
Pi steradian. So what is it then? G into sigma into pi steradian. By the way, here the diagram which I made for you to understand. This diagram I made, I assumed a cylinder around it. That cylinder does not, it is a different imaginary cylinder being taken here. Here I have not drawn that imaginary cylinder. This cylinder is not that imaginary cylinder, because that imaginary cylinder I will draw by taking P as the center, and around it I will draw that imaginary cylinder. Understood? That will be another cylinder, for which I will say that when on that cylinder, when on any cylinder, if the solid angle subtended on that cylinder will become, corresponding solid angle subtended on that cylinder will become pi steradian. When the planar angle is 90, the corresponding solid angle on that cylinder will become pi steradian. Is it okay? The corresponding solid angle on that will become pi steradian.
Okay, sir.
Okay, right. So, and now once we know that what angle it is subtending, then what will be the force? Force we know will be mass of this rod multiplied by E perpendicular, mass of the rod perpendicular. So what that will be? That will come out to be equal to, what is the mass of this rod? Mass of this rod is, we can take sigma into dl into total, the length of the arc will be something r in, or maybe dm. I will take simply dm. Let it be dm. Then dm into g into sigma into pi. Dm into g into sigma into pi will be the force, perpendicular force downwards. What will be the net force now? Net force will be by integrating g constant, sigma constant, pi constant. Sigma is for what here?
Integral dm, sir.
Sigma is for
For unit areas.
for what? For which plate? For the rectangular plate.
Rectangular.
Rectangular plate
Sigma
only,
is
yes.
for rectangular plate. But this mass here is not of the rectangular plate. This is of that curved
Yes,
surface, curved cylindrical, hemicylindrical part.
Integral rod we have taken now, sir.
dm integral, then we get g into sigma into total m. So finally we are getting g, sigma is mass of cylinder, mass of, let us say, base is capital M, let it be capital M, lower mass is capital M, and this mass of curved part is, let us say, small m. Then we are getting g capital M upon area 2r into L into, here it is pi and here it is m. That is the answer. That is F perpendicular. So are you getting F perpendicular as G capital M small m into pi upon 2R L. That is what
Capital M is curved surface mass. Sir.
capital M will be curved surface. Not this small. What are you doing? My God. This dm was for the rod. We were finding
rod element.
we were finding field on this point P. At P point, we were finding the field due to the rectangle. If we are finding field at P point due to the rectangle, then I have to multiply by the mass present at that P point. That mass is dm. So that is the mass of the rod, and then entirely.
Okay.
This is the mass. Dm is the mass of rod here.
Yes, sir.
dm is mass of rod element. Of a rod element. Where is that rod element? Of rod element on this cylindrical part. On the cylindrical curved part. Okay, cylindrical part only is okay. Capital M is for the rectangular part.
Rectangular.
Because I want to replace sigma. Sigma was a capital M by 2RL.
Sir, but we assumed it
No?
to be an infinite. Sir, we assumed it to be infinite
Yes.
cylinder, no, sir. Then can we write that 2RL?
Yes. Can we write it as?
2RL. That means L will be infinite,
No.
no, length of the.
Infinite means long cylinder. I said L is very very less as sorry.
Yes, sir. That means just you are comparing L with
I
R.
should say L is very very large as compared to R.
Yes.
L is very very large as compared to
That's
R.
what I am asking.
That was because of this reason that if L is very very large as compared to R,
Then solid angle will become 0, sir, due to the 2 parts.
solid angle this side will become nearly 0,
Yes, sir.
except at the edges. At the edges, solid angle will still be sufficient. But we are not bothered about the edges. So solid angle will be subtended in both sides. That will be 0. Is it okay?
Yes. Yes, sir, it's understood.
Right. Next, what else can we take?
Cube, sir, cube.
One other method I would like to give for this. Another method. This is one way. Here I did opposite. I did by the rectangular I find on the rod. Let us do opposite. Let us try to find out due to rod on the rectangle. That also we can do. This time I will find out due to rod on the rectangle. If I do that, let me try to make a rectangle first. Wait. Let me finish first. Please don't say anything. Don't even say anything. Don't start saying in between only. Sorry. This is that and this is the rod. Now, what will be the diagram for this? Let it be making some subtending some angle here, some theta angle, whatever that theta is, we don't need to worry about it. I want to find out due to this rod, the force acting on.
Sir, once again tell question, sir.
What?
Once again repeat question, sir.
Question is same question only. There is no different question. But now I'm tackling in a different way. Now I want to find out the force on the rectangular part due to the rod element.
Okay.
Last time I found opposite. Last time I found on the rod due to the this rectangular part. But now I'm finding on rectangle due to rod. Opposite I'm doing this time.
Okay, sir.
This rod is of some mass, maybe dm, and it has length L. So its mass per length will become lambda. That will become equal to dm by L. That will be lambda for this. Because we know in terms of lambda, I know the formula for field. So I can use that formula to find out this, right? So what is the formula for field? I think you know field formula is G into 2G lambda by R. Let from here some distance R away, there will be some mass. So I can say this is a perpendicular line and this is here area element dA. It is at an theta angle from the perpendicular line, and this side we have theta angle again. dA will be perpendicular to rectangle. dA will be perpendicular to rectangle dA vector, and this is along the radial line along which we want to find. We will write the field. What is the formula for field along the radial line? The formula for field along the radial line due to infinite rod is 2G lambda by R, and I am assuming it to be infinite. That is our beginning assumption only, that L is very very large as compared to the distances radius. So it is very very large. Okay. So therefore the field will become, if you remember this formula, do you remember 2G lambda by R or not?
Yes, sir.
So it is 2G lambda by R. That is E. Direction of this direction will be towards the this rod element. So it will be along minus R cap. It will be along minus R cap. Now I want to take force acting on this mass present here. Let us say it was capital M. This was small m. I am writing it as capital M. dm it will become d capital M, and let its density be sigma dash. Okay, and because other density I am assuming to be sigma, so it's this I am assuming to be sigma dash. All right, this only I assumed sigma last time. I think this only I assumed This only I assumed sigma, I think last time also, yes. Rectangular only, right. Then what do we get? Then we get sigma into dA is equal to d cap force dF on this small area element. Force on this small area element will become equal to what it will become, say something. What will that force become? Dm into E. No, not dm into d capital M into E. D capital M into E. Understand always. We will apply. We will find out the force in such a way only. Always. How do we find out? We will find out always by
EM into E.
taking mass of this body, but field not of this body, field of other body. Mass of this body, field of other body. That is how we will always do. So dm into capital E. Now, if I want to integrate it, before integrating, let me write it properly first. Sigma into dA into E, but I don't want dF also. I want dF perpendicular, and you know reason why? Because I know finally it will be along perpendicular direction only. Net field will be perpendicular to the area, so I will take dF perpendicular, which will become sigma into dA cos theta into E, which will become sigma into dA along radial line into E 2g lambda by R. Then what it becomes finally, dA. Wait a second, is it something going wrong here? By R square it will be, sorry. By R, no, it was R only.
R only, sir.
It was R only, then why?
Yes, sir.
It was R only. This time we are getting like that only. It was R only. So no problem. That also is okay. What we will write this thing as? We can write sigma into 2 into G into lambda into dA along radial line upon R. Upon R will also dA along radial line upon R integral. This you want to find out. That will be the net perpendicular force. All right. How to find dA R upon R? That we can find out somehow, I think so. Let me think of some way. Let me take not a small element here like this, but I will take now a complete strip here. Let me take a complete strip like this. If I take a complete strip here like this, this is the DM element. Then what will be this length here? This length will be simply d, let us call it d, what you want to call it, dx. And this is L, let us say, dx into L. Then this will become dx into L. Dx into L sigma into 2 into G into lambda into dA. No, wait a second. Then I should not write dA. I think I should write dA only. dA only and into cos theta only. After that, here also it is dA into cos theta. Then I can write dx cos theta. L is upon R integral. What it becomes now? See, 2G lambda dl. L taken out. Dx into cos theta divided by R. If you understand it, what it is by geometry, you can tell me quickly. What is dx cos theta into R? Now let us take from another view. If I look from the top, then this is the rectangle, and we are talking about some area element here, and this is here dx length, and this angle is theta. Now I am talking about dx cos theta. What will be dx cos theta? If you know clearly, dx cos theta will come out to be length of arc dl. If I take a perpendicular to radial line, that will come out to be dx. Wait a second, let me make it bigger. I can understand things, but to clarify, I have to make it properly. This is dx. This is theta. This is here r length. This was the rod element here. Here was the rod element, top view. And this side is the rectangular element. Now, this length is dl here. And that will be component of dx in this direction. What will be component of dx in this direction? That I can tell you by knowing this angle is 90. 90 minus theta, again 90. It is perpendicular to radial line. Then this will be 90 minus theta. So dx cos 90 minus, wait a second. It is 90 minus theta.
Dx
That will be
cos
theta.
theta.
Dx cos theta. So dx cos theta divided by r will be nothing but dl, length of arc upon r, and that will be d theta. So which theta is same? This time it is not solid angle. It is coming out to be just this angle in radians only. It is not solid angle. Sigma into 2 into g into lambda into L into d theta only. That's it. That d theta integral.
Sir, integral will
become,
become, sir. Then theta.
integral will come pi by 2. total angle that it subtends. If I take from one side to the other side, then total angle it will be subtending will be pi by 2. Now it is just pi by 2 because it is in radians. That is f perpendicular. But we know already lambda was what? Lambda was equal to lambda was written somewhere. Lambda mass per unit length. Yeah, this is lambda. dm by L.
dm by L.
Lambda mass per unit length was dm by L. So this comes out to be sigma 2 g lambda L by 2 into pi. Lambda, sorry, not lambda. No, lambda I have to remove. 2 g L pi. Lambda is dm by L. L cancelled. 2 cancelled. G sigma pi into integral of dm, that is f perpendicular. What is it coming out to be? G sigma pi into m. M is the mass of this curved part. Sigma is again same as before. M upon pi RL into pi into m. So are we getting same result or different this time?
2 is gone, sir.
No, we are getting very much different. Wait a second, I have already committed some mistake. Let me check once. Sigma into dA cos theta into E.
Sir, sigma also
E
should be into mass, I think. Last time,
sigma is constant only. We can take it out of the integration. At last, we can put in terms of mass, no problem.
okay, sir.
At last, we can put in terms of mass, but in the beginning, it is okay. Sigma into dA. Sigma into dA cos theta into E. So E will become here 2g lambda by R. That is correct only, I think. Then it will become 2g lambda is outside, sigma is outside. Then we are getting it as dA cos theta divided by R. L into dx by R. What is happening here? Nothing seems to be wrong. Why are we getting a different answer then? G sigma into dA by R square cos theta into R cap. Then this is G sigma by R square into dA R into R cap. That is G sigma omega. That is G sigma pi steradians. What do we get here? G sigma into dr by R square. Okay, G into sigma into d omega. Integration G sigma omega. That is G sigma into pi. Next time, and sigma we are writing as then multiplied by mass m dm. Dm integral G sigma pi m we got. Then we are getting this thing. Next time we did the same thing. Then we are getting G sigma pi m only we are getting here also. What is the problem? Let's see. Last time what we got? G sigma pi m only. What is the problem then? Same only we are getting. Hello?
Yes, sir.
Yes,
Hello?
sir.
It is same only. Not same?
Sir, here
Same only.
sigma is of
Sir, here sigma you have taken wrong, sir. Second one.
Second one wrong
M
means
by,
what you mean by is wrong?
M by 2RL we have taken, sir.
M
Area as 2RL. But here we are taking pi RL.
pi r.
M by 2 or L it will be, right?
Yes.
Sir, got it.
That only, same only. Both ways we are getting the same result.
Sir,
Exactly same. Right or not?
right only, sir.
Okay. Wait a second. Let me just one last time. One more method, third method I will give you. In fact, there are two more methods by which I can do, but those are different. Those we should not use because those are lengthy by integration. Lot of integrations involved. But I have derived by those two different methods also. Let me share this one also. This one also will be nice if you know this one. This one is if I take a again in general. Okay, let me give you a general method. In general, if there's a dm mass here and there is any such area here, and I want to find out the perpendicular force, then what that will be? As you know, the perpendicular formula will be g sigma omega. It will always be. Where this is omega subtended, that will be E, and then multiplied by dm will be the f perpendicular always. This we know in general, right? This is always true. So g into sigma of this plane area into solid angle subtended on the dm, so into omega into dm. That is always generally true. So
That is
I think this was only my first method was that only, I think so. So same only, right?
yes.
G sigma into omega into m. Means you can remember this thing that it is G sigma omega is F E perpendicular. If you remember this, then it is just one step answer, G sigma omega m, and remaining is your smartness to understand that what is the omega subtended by any element on this area. So any element, because it is subtending equal angle in all four possible directions. So what fraction will go to this side solid angle? 1/4 of the total solid angle, and 1/4 will be 2 pi by 4. That will be pi by 4 pi by 4. Sorry, 4 pi steroid 4 pi by 4. That will become pi. So it will just become g into sigma into pi into m. It is same only, I think, as first. Same only. Okay, same thing. But I'm just telling you in quickly in short that this is how we can do it easily. Anyway, next we have
Square
yesterday I was playing this hollow cube. Let us do this one now. Now I want to see your smartness. Can you find out for it or not? Hollow cube, force acting on one face due to the other 5 faces. Force acting on one face due to the other 5 faces. I think you can still not do. Let me explain something before that. After that, you will do it. First of all, I want to explain something. What is the formula for disk? Can you find out the formula for annular disk also? Annular disk means disk with a cavity. If I give you a disk with a cavity and I ask you what is the field due to that, force due to that, or field due to that, perpendicular field due to that, can you find it out? This
Yes, sir.
alpha angle
Yes, sir.
below and the beta angle outside. Then we know two solid angles will be there, omega 2 minus omega 1. That will become 2 pi into 1 minus cos theta 2 minus 2 pi into 1 minus cos theta 1. And we know when
Cos
we want
theta
to take
1.
the difference of solid angles, then we will be getting the difference of solid angles as 2 pi cancels.
Beta.
We are left with 2 pi into cos of alpha minus cos of beta at last. That will be the effective total solid angle, the difference of this outer minus inner. Because in this place the mass is existing and inside there is a cavity, so cavity part we have to subtract. So we know this, and once we know this, then what will be the field? What will be the force acting here? Force acting is G sigma omega. We can get it quickly now. G sigma omega will be
G sigma that
the
one.
field.
Field.
That will be field. And once we know that field, we can find out the force acting on any particle which is located in this particular position. We can find that also. Using this, I can ask you this question. If I have a square plate, and from this square plate I am at a distance at a distance a by 2 perpendicularly, what is the force acting between this and a mass m here? Or better way of asking this question would be this. I am giving you a sphere of radius. I am giving a sphere of radius a by 2 kept on a square plate. Kept on a square plate of side length a by a. What is the force between these two? This mass is m and this mass is m. What is the force between these two?
You can consider outer sphere mass will be corner center.
Here as point, yes, sir, center.
This can be assumed to be as a point mass at the center, and for this,
Yes, sir. At the distance
this,
of a by 2.
That and multiply by mass.
what solid angle it subtends at a by 2? That is the main concern here. If you don't know, then I cannot do it. Sigma of the plate is m upon a square. That we got. Now answer is g sigma omega into capital M. That is the answer. But what is omega?
Amama, Josley.
What is omega? If you are able to tell omega, then you get the answer.
Omega is a square upon a by 2 whole.
Omega is very simple to tell here. In this case only, especially
Yes, sir, a
because
square upon.
no, not that what are you saying a square upon something. Are you even understanding how do we find out? We need to take perpendicular component of area here. These areas are not in the radial direction. These are in different. This is the area. I have to take dA cos theta, and then I can convert it into solid angle form.
Understood. I was saying whole as single thing from center. Elements in it.
Not element. Nothing is required like that. We no need to waste so much time. I can quickly say. I can say its solid angle is 4 pi by 6. Okay, tell me now. Why is it 4 pi by 6, and how I am able to say it quickly?
6 faces.
Yeah, 6 faces are of the cube, and sorry, not able to draw it properly. One face. What is happening here really? When I want to do fast, it becomes more slow. Second face. Third face. 3 faces are visible, and other faces are also there. And this is in between these 3 faces here in the center. Okay, imagine it is a cube only, and it's a proper cube. And one will be here at the center. So center one will be equal. It is equidistant from all faces or not? The center one will be equidistant from all the faces.
Yes, sir. All sides.
Because it is at a distance. It is at a distance a by 2. And if it is equidistant, then the share of solid angle formed at the center by each face will come out to be equal share. In those
By
cases,
6.
in those cases only,
Sorry.
when it is at a distance exactly perpendicular distance a by 2. In those cases only. Then therefore I am able to say for each it will go 4 pi by 6. Then force will come out to be equal to g sigma m upon a square into omega 4 pi by 6 into capital M. See
By 6 into m.
how easily we are getting that, right? Now second question will be that I wanted to ask. This one. What is the force acting on one face due to the other 5 faces? This is tricky.
Sir,
Long back it happened, but it was difficult for me at that time. Again, we can apply same method as I have applied before. That method we can apply here also. If I take a Gaussian surface which is very close to it, I imagine a very thin layer like a paint layer. Imagine you are painting the cube, but the layer of the paint that you are putting on the cube, that is like a new Gaussian surface. Think like that. Then what will be the flux passing through that Gaussian surface through one face? What will be the flux passing through one face? I think you know equal flux will be passing through all sides, and by Gauss law, E dot ds in the closed surface is equal to 4 pi g into mass enclosed. If I don't worry about signs, otherwise there will be one minus sign also. Magnitude wise it is this. Magnitude wise it is equal to 4 pi g into mass enclosed. Let us consider magnitude wise only. Then what will be the flux? We know total flux. That is the total flux. Out of that, what will come through one face? Phi through one face. Phi through one face will be what? 4 pi g into total mass of the cube. It is a hollow cube first of all. It is a hollow cube. It has just 6 plates. Imagine there are 6 plates upon 6. That will flux through one face. Now, what will be through one face, but due to local field? Local field means imagine there are no other faces. Only one face is existing. when only one phase is existing, then it will also produce its own field or not? Due to its own field only, what will be the flux passing through one phase? Imagine you are taking this plate and you are painting it both sides. You are painting it above and you are painting it below. If you are painting it both sides, then the volume formed by the surface formed by the paint, will it be a closed surface or open surface? Surface formed by the paint, will it be open?
Close.
It will be closed surface.
Closed.
And what you expect in that
Like
closed
a
surface,
frame.
what should be the same formula will be applicable again? 4 pi g into mass m divided by
Sir.
mass. What mass of this phase? This mass is m by 6.
M by 6,
Already m by 6.
sir.
Yes.
4 pi g into m by 6.
By 6.
Into 2 no, sir.
But what will be the portion of that coming out? This is the total, right? This is the total flux coming this side as well as going downside. But if I want only coming upside, only outside, phi in the one phase locally due to local mass, and that also coming outside only, not going inside, coming outside only. What that will be? That will be this divided by 2 again, because 50-50% it will go.
Sir.
Will it go 50-50% both sides or not? 50% this side, 50% other side. So if I take one side only, on one side, due to local mass, it will be due to one plate. We can say like this. Let me try to make it in a better way. I can say flux in one phase coming outside, that is outside only, coming outside, and that due to remaining 5 phases. Let us say remaining 5 phases. Remaining 5. And now flux in one due to same phase only, due to same plate only, and coming outside. This is also going out and this is also coming out. Just think in that way, coming outside only. But when here we are taking coming outside, then it will be 50% of that. Yes.
In the first case, 4 pi gm by 6. That is due to that means if you consider a clip due to one phase, you are telling to other phase how much it's coming flux now, sir. By that means field of one phase.
Wait a second. I did something wrong here. I should say flux through one phase, but due to all contributions, due to including this also, due to all.
Yes, sir. Okay, sir.
All. That I should have written. Sorry, that was.
Then okay, it's clear. Yes.
And here flux in one phase, but due to the same plate coming out, due to all.
Yes, sir, I understood this.
What will be the flux now due to remaining? Now I want to find due to remaining 5. That I can get by subtracting the from 5 1. I will subtract this other one, and then I will be getting that. Then I will be getting due to remaining 5. It will be coming out to be 4 pi g capital M into total was 1 by 6 minus 1 by 12, I think, which will be.
Yes, sir. Again 1 by 12, sir. That means pi g m by 3.
Pi g capital
M by 3. 3. Yes, sir.
That's the flux coming out. This is due to remaining 5 phases, and if it is due to remaining 5 phases, then again I can do the same thing now. On this phase, I want to find out the field. Let us say the field is in different directions. And what will be the formula for the force? Force formula will be E due to the remaining phases multiplied by mass of this phase. E due to remaining phases multiplied by mass of this phase. So I can say dm into E integral. But I also know that this integral will become equal to dm into E perpendicular also. How do I know that? It has horizontal component, but here also there will be another equivalent mass here. By symmetry, I can say.
Yes, sir. All horizontal get cancelled out.
Horizontal will get cancelled. So finally, net force will come out to be only in perpendicularly outward direction. So I can say dm into E perpendicular. And if I'm saying dm into E perpendicular is equal to dm into total E, what is dm into E? First of all, dm into E will come out to be equal to dm into E perpendicular
G capital M by 3 into
sigma into dA into E. And what is that now? Sigma into dA into E, dA dot E I can say, because it's perpendicular only. So I can say dA dot E also, dA dot E, because I have to take only that component which is perpendicular direction. Then I can take component of, this is let us say dA vector. I can take component of dE along dA. Then I can say dA dot E, sigma into dA dot E. What is dA dot E here? Sigma outside, dA dot E is nothing but the net flux passing through this plate. That E dot dA is nothing but net flux passing through this plate. So what is it coming out to be? Sigma into phi. What is the flux passing through this? Due to remaining. Sigma into phi due to remaining 5 phases.
sir, pi g m by
That is coming out to be now sigma is the mass per unit area, and the pi gm by 3 we know already. Then we get here
Yes, sir.
mass per unit area means m by 6. M by 6 already mass of this or m by 6
Yes,
is
sir. A
sigma
square,
is
sir.
m by 6 a square is sigma into phi of
Into pi gm by 3.
pi g m by 3. So what answer do we get? Pi g m square.
Pi gm square by 18 a square, sir.
Exactly right. Pi g m square by 18 a square.
Yes, sir.
That is answer at last. Okay. I asked you yesterday to find out, I think, force. To do this, I have done already. Right.
Once
Now
can you
next,
Hollow you are done, sir. Solid you asked to us.
that you have done, I think so. I have done already. Solid one. Okay.
Yes, sir.
Yes, sir.
So we are getting this thing. Sigma into phi is the force on one face, and phi, why I am taking phi due to remaining? Always this is happening. Mass of one body into field due to the other body. Not like this mass of one body into field also of that body. Not that. Mass of one body into field due to the other body. That will be the force acting on that mass.
Yes,
Okay.
sir.
Right. So next we can take example of solid sphere, and on that let us say I have a cavity inside the solid sphere with a cavity. Let's say cavity inside the solid sphere. How to find out the force or the field inside the cavity? Can you find out the field inside the cavity? Field inside cavities. Now field inside cavities I will find out. First I will take cavities in uniform bodies, cavities in uniform sphere or uniform cylinders. That only I will be taking. Cases of cavity. Already this diagram was drawn here. Okay, I could have taken this. Let me take those only. Their diagram. Cases of cavity and resizing this. Yes. So first of all, let me find out field at a general point P, and this one is at the center of second cavity. This one is center of first cavity. Line connecting the centers. I want to find out the force at P point. Field at P point, and let this be mass of density rho. Inside there is a cavity, and total radius may be something capital R. Cavity radius may be small r. Distance between the cavities may be d. How to find it out?
Cavity 0.
Solid sphere and cavity solid.
Total minus portion of cavity. We will do this way. First, we will find due to total minus due to cavity.
Yes, sir.
So, for that to find due to total, I think you should be knowing how to find due to total first. If you don't know that, by Gauss law, we can find due to total. How to find due to total? Let us find due to total first. Due to total, at any distance r, the field is always, first of all, radial inverse. It will be like attractive field. And this is the mass enclosed. This red color is the mass enclosed. So, what will be the field towards the center here? If it has total as radius r, we don't need that, although this is rho density. Can you find out the field towards the center? I think by Gauss law again, flux will be.
Done, I think, sir. That one.
Yeah, sir.
No, I know you have done, but I'm doing it again so that you remember it properly. We have done it, I know, but I don't want you to remember the formula. I want you to derive it every time. Whenever you face this question, you are facing every time, do it again. Don't learn the formula. You will not be able to learn up to the examination. Do it again. E into 4 pi r square is the flux, because it does not take much time to derive. It is one step only. E
Yes, sir. Assuming you just follow
E
imaginary
into 4
sphere
pi
and
r
with
square is equal to G into 4 pi into G into mass enclosed.
enclosed
4
is
pi
4 rho into 4
into
of
G into mass enclosed. What is the mass enclosed? Mass
Rho into
enclosed
rho
is
into 4 third pi cube, sir.
rho into 4 by
4 third
3 pi
cube. R
r
cube.
cube which
Yes,
I
sir.
can write E as 4 by 3 pi
Oh, the
rho G R.
Yes, sir. Now in
EH
Now,
surface into R by R will get.
this is also, wait a second, this is not vector form, this is magnitude wise, vector form. 4 by 3 pi, because I have to take vector difference, no? I cannot write magnitude wise only. I have to take, it will be minus R also. Radial
Minus R
inwards,
bar
it will be
S.
minus R.
sir.
If I take radial vector to be outwards, normally we take radial vector to be outwards. It is opposite of that, so it is minus R cap inwards. If that is the case, then here what is the radial vector now in this case? In this case, this radial vector is PC2, PC1. So I can simply take E due to the total. E due to total is 4 by 3 pi rho into G into, from where to where? P to C1.
PC1.
I can take P to C1 vector. No need to take minus. It is already towards the C1 side. So no need to take minus. What is E2? E, if in cavity there is a mass, let us assume there is a mass in the cavity also.
Yes,
And that is
sir.
also having same density rho. Then it will be 4 by 3 pi rho G P to C2. By same logic, it will be in different direction. Now it will be in the direction from P to C2. Now I have to take the difference of E1 minus E2 because this is extra taken, that is not existing. I have to subtract it. E1 minus
Then we get
E2 will be the
PC1
remaining
bar
force
minus
on this.
PC2 bar into 4 third pi log.
So it comes out to be 4 by 3
Rho G into
pi rho
PC1 bar minus PC2
G
bar.
PC1 bar minus
PC2.
PC2 bar, which is also PC1 bar plus C2P.
Yes, sir.
PC1 minus PC2, I think you know that can be written as this.
Yes, sir. Minus
Which can
PC2s plus C2P.
C2P plus PC1. So we are going from C2 to P and then P to C1. So we are going from C2 to C1.
C2 C1.
So what is E coming out at last?
D, sir.
It is
4
coming
third
out to
pi
be
rho
equal
G.
to 4
4
by 3 pi rho G into C2 to C1 vector. Very important, very, very important result, very significant and very strange as well. I don't know you find it strange or not. I find it strange, definitely. I find it strange. Why it is strange? See the features of this. It does not depend on P point's location. As long as we are inside the cavity, as long as we are inside the cavity, and the cavity is spherical, first of all, this cavity is spherical. As long as we are inside any spherical cavity, the field will always and always be pointing towards C1 to C2 direction. It is always pointing in this particular direction only. That is amazing result. It is this side, uniform, everywhere same, everywhere same, everywhere same, like this. Uniform field, see, out of two fields which are pointing radially inwards, out of two fields which are pointing radially inwards, we are subtracting those two and we are getting a field which is just
Again, yes,
uniform
sir.
field.
Yes, sir.
Which is just a uniform field. That is amazing result. And this amazing result has many applications. Why it has many applications? Inside it, even if I give you a toy inside it, and I ask you very complex shape, any complex shape I give you, and I ask you what is the force acting on that complex shape due to the, or what is the force exerted by that complex shape on this remaining part, it will be so easy because the force exerted by this complex shape on the remaining part will be same as the remaining part applies on that, and remaining part applies on
Yes,
it.
sir. Electric field into mass of the toy.
Yes, and it is constant everywhere, so it will be very
Yes,
simple
sir.
to tell. If it is not uniform, then it will be difficult. We may have to integrate. Here we need not do anything. Put anything inside it and put in any
Same
shape
field it
also.
acts.
Doesn't matter. Always it will come out to be same force. It is amazing result. That will be always the field we know already. That field will be equal to this thing.
Sir.
4 by 3 pi. 4 by 3 pi G
C2
rho G
C1 bar.
to C1. And once we know that, then from there we will get the force on any other object inside it. So sometimes we can ask questions based on that. For example, I may, or not only the question on force, I may ask the question on force also. I may keep something inside it and I may say, this is a cavity. Now cavity is filled with water of mass m or liquid of mass m, or cavity is half filled with liquid of mass m and it is half filled with some floating object inside it. Whatever complex shape thing you want to create now, doesn't matter. Answer will be obtained easily as long as you know the mass of the inside body. And they may ask in another way, they may ask what is the force exerted by this liquid on the remaining part, but it is same as the remaining part exerts on the liquid. And what exerts remaining part exerts on the liquid, it is so easy to tell, we can tell it easily. So the force exerted on this liquid, which I am drawing here now,
Equals to
will be
mass of
just
that liquid
4
into
by
GM
3 pi
into C1.
E into rho into mass of
H.
this liquid. Understood?
Good, sir.
Right. Next, one more thing here. If I can ask this question also now, because it is a very simple case, no? So why don't I just a little bit, we can say, play with this. We can say there's a point mass here, and or maybe some particle, and I'm projecting it with velocity u. It will follow projectile motion. It will go like this. Will it follow projectile motion or not?
Yes, sir.
As long as small m is very, very less as compared to the mass of remaining portion, so that otherwise the remaining portion may start rotating, that may also start moving. But I'm assuming the remaining portions remains stationary only linearly. It is like big thing, like Earth or some planet, big object, and the other one is a small particle here. And when we project that particle, then inside it, it will be just following a projectile path. I can ask you this thing also, that if it is projected with velocity u and it passes through the center and then strikes the other side, what time it will take, etc. What will be the so many things I can ask in this now, based on this simple idea, because it is very simple question now. I can ask this thing, that I am releasing one particle here. I am releasing one particle here, and it is allowed to fall towards the center of the other. Then what time it will take to reach there? It will be just simply root 2 of this height. It is radius r. Height will become here root 2h by g. G effective will be this. We already calculated that G effective. Then height is here twice of small radius upon G effective. Then that will be enough time taken to go from here to here. See how easily we are able to answer all these cases. They may ask this also. Not only this. In fact, this question I can ask even if I don't assume the mass to be negligible. Even if I say masses are comparable, let this mass be m and this particle's mass also be m. And I'm asking this question now, what time it will take to come here, or it will collide with it, it will return back after that. Let the collision be elastic. Now it will be bouncing again and again, and I can ask you this question, that what time it will take for the particle to come back to its initial position, go A to B and B to A back. Then it will be like, first of all, we can take reduced mass. Why? Those cases, whenever m1a1 is equal to m2a2, whenever m1a1 is equal to m2a2, then I can use the concept of reduced mass. I can write mu into A relative.
A relative.
We can do in that way also. And how to find out A relative? A relative I can find out this way. I can get, first of all, force. What is the force acting? Force is m into 4 by 3 pi into rho into g into d distance between these. That is the value. Rho is given to us, let us say, right? Now, this is force. Let its mass be m1 and m2, and this is m1 here, this is m1 and the other one is m2. Then that is the net force, and force upon m1 will be the acceleration of one mass, and force upon m2 will be the acceleration of second mass. The second means bigger mass. This mass also will accelerate. Both will accelerate towards each other. So if they accelerate along the radial line in this way towards the center, then it will be so simple. There will be no torque also, no rotation involved. Just simply a1 is equal to f upon m1 and a2 equal to f upon m2. So net will become f upon mu will become a1 plus a2. 1 upon mu is 1 upon m1 plus 1 upon m2. If you remember, 1 upon mu is equal to 1 upon m1 plus 1 upon m2. So f upon mu will become a1 plus a2, or that is equal to mu into A relative. Can we get A relative here? Yes, we can get. I think we can get A relative easily. So we can find out after knowing A relative. After knowing A relative, what time it will take to go down? Root 2h by A relative. What time it will take to go up? Again, same time. So what will be time for one oscillation? Time for one oscillation will come out to be 2 into root 2h upon A relative. We got it now, and it will appear to be complicated for those who are not able to picture this, but it is very simple problem in fact, and I hope you have understood it now. Understood or not?
Sir.
Right. Right. If you want to make it further complicated, I can make it further complicated, but I think this much is enough to clarify the main concept. I can do this thing. I can consider the rotational effect also into account. I may say it will collide in such a way so that it will change the angular momentum of this, and it will start gaining some angular velocity in opposite direction. And then it will collide on the other side. That will again reverse its angular velocity back to the same direction. Then it will be performing some angular SHM also, angular motion, angular oscillation. That also we can do. That also we can do. That also we can discuss. Not a big task, okay? But no need right now. Maybe I will frame some question later on. Then I will tell you that. Case is not yet over. I will come to case of tunnel. We can have small cylindrical cavity. If it is small cylindrical cavity, we call it sometimes tunnel also, tunnel inside it. So that cases of tunnel also I will discuss. What will be the force acting on a mass which is inside the tunnel, etc., etc., all those things. For the timing, first of all, this thing we have to answer. If I have a long cylinder, long solid cylinder with a cylindrical, long solid cylinder with a cylindrical cavity. And again, same way as last time we did. Try to do in the same way. Let me see whether you can get the answer.
Again, considering a point.
Do once. Then after that we will talk. Okay. If you can go back to see what is the formula, how we derive for, although by Koslov we can again derive. If you are not remembering the formula for the cylinder, then you can derive again by using Gauss law. It is so long that I cannot draw its edges. So don't think that the diagram is complete. This diagram is not complete, obviously. By the time I am decorating it, you should be getting the answer.
Sir, answer got.
Are you getting E as this only, which I obtained here? 2
Yes,
pi
sir.
g rho
2 pi
minus r.
GB. Yes.
Then we will be getting E1 minus E2 again. And that will come out to be 2 pi taken common, G taken common, rho taken common. Let me give you a direct answer. Your answer should be
Yes,
C2 to
2 pi
C1 again.
G rho R will
C1,
get
C2, C1 only, sir. C1.
That only?
Sir.
2 pi G rho R
2 pi G rho
into R also will get.
minus R vector will be towards, it will be radial inverse, it will be attract. This is, see, it is magnitude wise relation. Why it is magnitude wise? Because when we wrote the formula E dot ds, then it is a dot product. So by dot product, we cannot get
Yes,
sign,
sir.
but we know how the direction will be. That sign we know ourselves. that sign we know ourselves that this force will be attractive force. If it is attractive force, it will pull the mass towards it. If it is pulling the mass inwards and force is inwards, then force upon mass which is field, that also will be inwards, because E gets its direction from F, and F is towards the center. It will be attractive force towards the center. So E will also be in the same direction. So here I have written with direction. Why I have written with direction? Here I was not getting with direction. Why I wrote with direction? Just because I want to finally find out the resultant field, and that is a vector quantity. So I have to take care of directions properly. I cannot get the resultant field without taking care of directions. Okay. Understood now?
Understood.
So then this must be the answer. Same type nearly. Will it be uniform again? I think it is again uniform only. 2 pi.
No, only sir. C to C1 bar.
It just depends on the perpendicular distance between the axes. It just depends on the perpendicular distance between the axes. This diagram, by the way, means top view diagram. It is from top view where we are looking at only cross section part. Okay. So that is the answer. Again, some nice result. Right. Now, again, as we did last time, can we do the same thing again over here also? For example, by taking a mass and playing with it, maybe throwing it, and then now it will be, in fact, one more advantage. This will be like a horizontal surface also. So we can, in fact, ask such questions here also, and we will be able to answer it easily. If I assume one assumption is given that mass of the cylinder is very large and this particle is very tiny. Here that assumption will otherwise also be true, because we are assuming a infinite cylinder. We are assuming a very long cylinder. So this assumption will also become true. Okay. So then it will be correct. In such cases, we can ask such questions, or we can ask another question in ring or any other shape, complex shape, any other complex shape, cube, etc. Whatever is kept, shape will be complex, but force will be simple. Mass of that shape multiplied by net field. That will be the answer. Right or not?
Yes, sir. Uniform electric field.
Uniformly. Inside it is uniform. Outside it will not be. Inside it will be uniform. Outside it will be different, and that's
Yes, sir. Outside, because of the mass is getting thin.
But method is same. How to find outside field? Outside field also will find out by the taking the vector
Field at
difference.
that point into mass.
Always we can take the vector difference and we can get the answer from there. Okay. All right. Next we can have. Now I think I can go to that case of tunnel. This is also like a cavity only, and but this is a long and narrow cylindrical cavity. We can say tunnel is nothing but tunnel. It is tunnel, or we can say it is long narrow tunnel, or it is long narrow cylindrical cavity. It could be cylindrical, by the way, or it may not be cylindrical also. Whatever the shape of this may be, it is just a tunnel. It could be a tunnel with a cuboidal surface. Cuboidal means that kind also. Now question was, cases of scaling also I have to take. There are so many things which I can take now also. And then I will take those cases where we cannot find out the field, but we can still estimate the field. There will be some questions which will be asked based on where we cannot even find out the field, but we can still estimate it. And this is, for example, let us say this is of mass m, and this is maybe 3m. What is the force between these two hemispheres? We can ask this question also. What is the force acting between these two hemispheres? Okay, wait a second. Come to this long narrow tunnel first of all. So, tell me the question which you can answer. First, you have to tell those. Do you know what is the force acting at a distance smaller? If it is r, density is rho, or mass is m. I think you should know this graph. Everybody should remember that the graph of g, or acceleration due to gravity, as a function of r, it varies like this. Do you remember it?
Yes, sir.
Then we can say G at the surface into small r by capital R. Or I can write it as G m by r square into small r by capital R. Or I can convert this into other forms also. For example, I can write 4 by 3 pi rho into G into small r. Sorry. Yes,
Small r
that only. That only. These are all same. This is G at the surface into small r by capital R also. G at the surface is Gm by R square. These are all same. Because the tunnel is such a small tunnel and narrow tunnel, it is very narrow. So we can assume the mass of this to be negligible. So we can assume that it will not create any difference in the fields. Nearly fields will be similar only. So what will be the force acting on a small mass kept here on the frictionless tunnel? Long, narrow, and smooth also. Let me mention it, smooth tunnel. Can you find out what is the force acting on this? And if it is rough tunnel, then also no problem. Then I will ask you two forces maybe. One perpendicular, that is like a normal, and another one like horizontal. That also I can ask friction. If friction is existing. Otherwise, I may ask you, not friction, I may ask you what is the horizontal acceleration. Because in absence of friction, the force is in this direction. That will cause some acceleration along the tunnel. I can ask you what is acceleration along the tunnel. That also I can ask you. Depends on the situation. What you have to find out for the time being, take this small mass as small m and find out normal here. And find acceleration, assume friction to be 0. If friction is 0, find acceleration. When the angle made is theta, at that time you have to find out. Please do it. Getting? Hello?
Yes, sir.
Audible.
Okay, then you try it once and let me drink water by that time. The formula is also written in front of you. It should not take much time for you. I know what you are doing from so on. Just make a free body diagram. You know which direction the force will be acting on that. Mg will be acting towards the center. That we know. Take the component of Mg perpendicular to the plane, this tunnel. Then that will be giving us normal direction. Normal will be equal to that. Take the component of Mg along the tunnel. That will be giving us acceleration. It is simple task. Getting or not?
Getting, sir.
Getting, sir.
Observation. Any observation?
is G sin theta
About
plus
the
4
normal
pi.
action, about the normal action, I think you may have observation that the normal action is independent of theta. Right or not? For all values of theta, normal action value will be same. Is that right or not?
Yes, sir. Yes, sir. Yes, sir.
Very good. Finally, you said it. Very nice. So you got it right on it. So let me tell you how it is happening that way. See, normal reaction is equal to m into g at distance r, which is equal to g at the surface, into small r by capital R. Into this is m. Sorry, it is not. It is mg actually. Mg is component in this direction. That will be again multiplied by
Theta.
cos theta. And what
Cos
is small
theta
r
is
cos
equals
theta?
to
Small r
D.
cos theta is equal to d. Then we get m into gs upon capital R into small r cos theta, which is nothing but constant distance d, perpendicular distance, that is fixed already. And g at the surface is already fixed, that we know. We cannot change that. Mass we cannot change, radius we cannot change. So it is constant quantity. It does not change. Wherever we are in this tunnel, that normal force will always be equal. Very interesting. Why is it interesting? It is interesting because of one reason. Let me give you many. There could be many reasons by which because of which it is interesting. Let me give a mass in this tunnel, and I fill this tunnel entirely with something, and I ask you what is the force exerted on this mass by the total solid sphere. Then it will be so easy to tell, because I know mass everywhere will be total mass multiplied by the effective force acting on it. What is effective force? Effective G acting on it. Effective G acting on it is just equal to Gs into d by r. We know net force will be acting towards the center only. What will be the direction of net force everywhere towards this side? So I will be interested in this force. That will be equal to what? That force will be equal to this total normal direction acting on it. Okay. So effective normal direction acting on it everywhere is same. So if I want to find out the total normal direction, let it be not m, let it be dm. Gs constant, d constant, r constant. If I integrate it, then by integrating dm only, I will integrate, and that will again become same only. That will be again m into gs into d by r. Means independent of the fact whether I give a small mass here or I give the total mass filled throughout, it will be same normal reaction as long as the mass remains same. Is it understood or not?
Yes, sir.
Yes, sir.
That is interesting. One more thing. This is one tunnel. If I make another tunnel perpendicular to it, then same thing will happen. As long as the perpendicular distance from the center of both tunnels is same thing will happen or not? Then also
Yes, sir.
normal
Same
will
normal will
come.
act.
So I can say one more thing. I can cut not a tunnel. I can cut a disc. I can cut a total disc. I can make it this. Assume this is not just a narrow tunnel, but it was a narrow disc in between these upper part and the lower part. Small disc means completely I have chopped it by two planes. I have completely cut it by two planes, and I am asking you, what is the force acting on this narrow disc part due to the total solid sphere? Then again, same thing. The mass of that disc part into Gs into d by r. Is it right or not?
Yes, sir.
Sir.
That is true. Correct. So once you know this thing, that really offers us a lot of opportunities to find out many things. For example, I can find out from here. I can find out this thing also. What is the force acting between? What is the force acting between this shaded portion and the unshaded portion? How to find it out? I will take like this. I will take element by element. I will take a small element here, and on small element I will find out the way I told you here. If small element is at a distance small r from here, then perpendicular distance. This time I am taking small r as perpendicular distance. Okay, or let it be perpendicular distance. Let it be y. Maybe if it is y, then what will be the force acting on this small part due to the gravity? The force acting due to the gravity on this small part will be equal to
dm into
m dm into g at the surface upon small r into y. What is g at the surface? G at the surface constant, r constant, y is only variable, and dm is also variable. What will be dm value? This is r, density is rho. This is a disk now. It is a complete disk element. Disk element, because I want to find out net force on this by taking such disk elements. Net force will become. This was also equal to, by the way, I think you are thinking that how I am finding it that way, because it is also equal to gravitational force. Are you understanding it is equal to gravitational force or not? It is perpendicular gravitational force, we can say. It is perpendicular gravitational force perpendicular to the tunnel. So normal was equal to perpendicular gravitational force acting on it. So here also we are finding out that perpendicular gravitational force only. So it means we are in the right track. Don't think some of you may be confused now that it was normal and how I change it into gravitational force. But normal was equal to gravitational force. These were balanced with each other, right or not?
Yes, sir.
Therefore, we can do that. Therefore, I can integrate it to get the net force, gravitational force. What is that? That is, I think, equal to gs taken out, r taken out, dm. Dm can be written as rho into volume. Volume will be, now let me take this radius as small r here, this radius of the disk. Then it will become pi small r square into width of the disk, that is dy.
Now
Integral.
R square you have to written in terms of y.
Gs outside, rho outside, r outside, pi outside. Wait, is it right? What I'm doing, is it right or wrong till now?
Right only, sir.
Please see if I'm committing some mistake.
Right
Are you sure
only.
it is right?
Yes,
Sir.
sir.
Electric
let me
field
tell you-
into the distance.
Into why you forgot, sir?
Why I forgot, I think that's why I think something was wrong here. Why I
Yes,
forgot?
sir.
Yes, why was
Yes, sir. Why do you guys?
there? Why was there? So what do we get now? We get a very interesting thing here. Pi r square into y. No. Wait. Y into pi r square into dy into y. That is.
Again, R square as a capital R square minus y square.
We can write capital R pi into capital R square minus y square into y
realize,
into
sir.
dy limits from whatever distance was given. Let us say it was given. Let us say that the question was this: that there's a plane which is cut at a distance a and another plane cut at up to distance b. Then in between those two planes, whatever material comes, what's the force by the remaining material on this material? Or if I want to take the total up to the top only, then I will assume a plane here. Then it will be going from distance a to total radius r. Then I will put the limits from. Then I will put the limits from a to.
R2 minus A2.
Then we will get the answer from there. It is simple integration. I think you can do it easily. Can you?
Yes, sir.
Yes, sir.
Very simple. Okay. There is another way to find out the force between these. In fact, not another. There are one or two more ways also. But this is, I think, easiest way, which I have introduced now. One way, maybe I will take in fluid mechanics. At that time, I may discuss this problem once again. There, I will do it by a completely different method. Okay. This is one way. That will be another way. Now. Other question which I can ask here. I could ask many different questions. Okay, wait a minute. I have framed one only yesterday. One question I framed. Let me bring that here. This question, for example, can you do this one? Based on same idea, we can do this also. If you have understood that, you can do this one easily. You can take a screenshot of this question. After that, you can see I will show you another question also after
Okay,
that.
sir.
Sir, we could
This
proceed
question,
today, sir.
can you do this one? Okay. Can you do this one?
Yes, sir. Before problem.
Find the electromagnetic force between the shaded and the unshaded portion of a uniform solid sphere.
We'll try.
Same only as before. What?
I mean, before
Same as before question only, no, sir. This,
A to R.
Exactly same. Exactly same.
Yes,
The
sir.
idea is
Limit.
that you should not be confused by the electromagnetic part here, because normal reaction is nothing but it is like electromagnetic force. Normal
Sorry,
reaction,
sir.
friction, etc. Those forces are electromagnetic forces. So indirectly, I am asking normal, and normal is equal to the gravitational force. This will be balanced. So if we are finding the gravitational force, then we get answer. Means in the last question, we have to put A equal to R by 2, and we get answer.
2, yes, sir.
Yes. This one is slightly different. Can you do this one also or not? Okay, take a snapshot of this. Take a snapshot. It is a good question. You can try.
Okay,
I will give you solution. Okay. These lines, these blue lines are vertical lines, by the way. These blue lines are
hanged from that hinge.
vertical lines. Both of these blue lines are vertical lines here. Okay. Remaining everything is written here. You can read and you can answer it.
Yes.
Try answering it once. This one we discussed yesterday. Have you taken snapshot of this?
Yes, sir.
Okay, right. Right. Now,
I'm
tunnel
also,
questions are over. Tunnel question there.
Yes.
In tunnel, I can ask many other questions.
I'm also up, sir.
Huh?
Time is up, sir.
Time is up. Can you find out the acceleration for the tunnel case? Internal case acceleration. That is simple only, I think. Just
Found
cos theta will be replaced by sin theta. And that r sin theta will be the distance from the center. So this acceleration will be proportional to the distance from the center. It will give us very interesting result later on. In SHM, we will study about it. Whenever acceleration is proportional to x, but direction is opposite to the displacement from the center, displacement is this side and the acceleration will be opposite to that, then we call such motion to be simple harmonic motion. What that is, let us wait for some time and I will explain those things also. This thing we can do, I think. What is the force between m and 3m? Can you find it out? Say, hemisphere, solid hemisphere m and solid hemisphere 3m. What is the force between these two? Okay, I will give you a hint how to do. You can do it later on. You can find it out yourself only. You do it in this way. First you find out force between by taking upper part also m and lower part also m. Means total part you take as m only. Take the total part as or find out answer in terms of density. Assume the density to be rho. Here density will become 3 rho, by the way, because if radius is same and volume is same, then density will become 3 rho. Let us see. We want to find out force in between. First you find out between rho and rho only. Then we know that force is proportional to the product of masses m1 m2. So if we are able to find between m and m, then we can find between m and 3m also. It will be just 3 times that. It will just become 3 times that. That idea we have. So by that we can get. Is it okay? Understood or not?
We'll try.
That way we can get. Then there are some cases of scaling which I could have taken, and yes, this case I will be taking. I think tomorrow I can take these examples. Okay, then let us end it here.
Thank you, sir.
Right, okay, then bye.